Good morning, sir.
It's good morning and good evening, everyone.
Good morning, sir.
Yeah, today I would like to demonstrate there is a supervised learning technique is called KNN, K nearest neighbor supervised learning algorithm. So let us understand what sort of step it requires. And this algorithm is a little different from the previous algorithms. So let us understand how exactly we have to do all this. Clear? So firstly, steps required to predict given sample, right? Yeah. The step one is absolutely for every algorithm there will be sample data set is required. And step two is that feature scaling is important. And the third step is distance calculation. Distance calculation, which is going to be used Euclidean distance. There will be mathematical concept. Euclidean is the mathematical approach with this distance between two particular points are going to be calculated. The next step is that finding nearest neighbors. And majority voting. Majority voting. Final prediction. Yeah. So this algorithm, how it will work, let us understand properly with the mathematical steps. Then we go with a Python implementation. Is it clear? So let us go with the concern file, which is let me open. Yeah. Guys, I hope you are seeing my screen, right?
Yes, sir.
Yeah. So our problem is it is the categorical related data where we have a age and salary as input features. We wanted to predict a person can buy the laptop or not. It's a binomial classification. Are you clear? Age and salary are the continuous data, but the KNN algorithm is going to decide whether a particular laptop can be buy from the online or not. This is a related sample. So this will be the X, this will be the Y. So firstly, let us see, like already I told you that these are the steps we wanted to be performed so that finally we are going to get the prediction that which particular given sample is belonging to whether he will buy the laptop or not buy the laptop, which means if they buy the laptop, it will be a yes, otherwise no. If you look at sample data. If you look at the sample data, so absolutely this is the age. This is the table. So it is salary and age will be the x1 and x2, x1 and x2, and this is y, which is a dependent variable. X1 and x2 are independent variables, like they are the input features. This is the target variable. I hope this kind of a sample data you have seen many. Okay. Now, our problem is, our real-time problem is that there is a new customer will come where the person is will be a 30, the salary is going to be the 60. Whether he'll be likely to buy the laptop or not, we want it to be predict. This is the our problem. This is the unseen data. This is the unseen data in the sample data, because the sample data already trained by the KNN algorithm. Afterwards, this algorithm has to be predict that this particular query, this particular sample is going to be buy the laptop or not is our problem. Clear? Yeah. Now K means like KNN is indicates. Here we have to take K will be a 3. K we have to assume initially. It can be a 2, it can be a 3. Among them, the voting is required, right? Like let's suppose there will be sample. There will be the sample. There are many points are appear in the in the sample space. You are trying to predict this particular sample is belonging to any one of the category. It's like a clustering. It can be a classification related problem. So this point is going to be here. We are going to be take 3 closest neighbors to this particular red, that the distance will be calculated between this and between this and between this, so that whichever the closest neighbors will be identified, the voting, if these 2 points are going to be, if they are buying the laptop, absolutely this particular this node is also going to be buy the laptop. If these two are going to be the not buying the laptop, obviously the majority voting is not buying the laptop, hence this particular laptop cannot be able to buy the laptop. Likewise, this whole algorithm is going to be firstly calculate the distance vector by applying the Euclidean distance. We are going to perform certain operations, and step by step we have to go such a way that you will be able to understand. At this moment, in order to assume the mechanism of the KNN algorithm, we have to assume K is equal to 3. K indicates the number of points to be calculate the voting system, whichever the distance is more closely for that, it is going to be give you the prediction. Let us take now, I hope you have understand that there is a K and there is a new unseen data this. Okay, K indicates the closest neighbors. We are going to compare it. Let's see now. Absolutely. What do you mean by feature scaling? Feature scaling is nothing but it's a normalization. The KNN will uses the distance, right? Absolutely. The age, salary must be scaled out, where min max scalar is going to be applied, which means the data will be changed. Okay. So how exactly the min max scaling is going to happen? Absolutely, for every particular thing in a given column. So we have to identify which is the minimum value is there in the column and maximum value will be there. And absolutely in the salary column also, what is the minimum salary and what is maximum salary would be there. So this particular formula is going to be applied, and then we are going to get the minimum is 22 and maximum is 52. Salary is the minimum and as well as this. So now if you go ahead, now by seeing this particular formula, we have to be applied for every row of a particular column will be applied. Now what I'm doing here, you just trying to see. what I'm trying to hear. So this is the training data. After the scaling, feature scaling, after applying the min-max algorithm, which is the feature, then what happens here? This particular 22 will be called it what? The value which is from the column. You see, the value which is from the column, age column. What is the minimum value? What is the formula basically here? You see here, the formula is this. 22 I have taken here from the age column. From the minimum, what is the value is most minimum here? If you look at when compare with all the values, 22 itself is the minimum value and 52 is going to the maximum value. In the salary column, 40 will be the minimum value, 110 is going to be the maximum value. And then we are going to apply for every row for a particular column. This is the same formula, which is the min-max algorithm to perform this feature scaling. So accordingly, what I'm doing here, 22 is the actual value from the age column. This 22 will be the minimum from the age column divided by 52 is the what is column? It's a maximum column minus the minimum value, so that we are going to get a 0 as the value here. Okay. Similarly, we are going to perform for all the values. For all the values, so that these are the values you are going to get 0, 0.10, 0.83, 1.0, 0.8. These are the scaling values. And similarly, here for the salary column, the minimum, the actual value from the salary column is 40, but the 40 is the minimum value. Minimum value. And like absolutely the 70 is going to be the maximum value. Yes or no? So that we are going to be obtained like this. 0, 0.14, 0.71 and 1.0 and 0.79. These are the scaling values from the salary column. And finally, obviously, these are the yes or no or the it is a binomial classification. As a whole, if you go down, absolutely, we wanted to find out. Unseen data has given us a problem, right? The person age is a 30 and salary is a 60,000, we can say in terms of thousand. So how you are going to calculate? Absolutely 30 minus 22 is what basically, absolutely the 22 is a minimum value. Yes or no? So here a maximum minus minimum, if we divide, like if we subtract, 30 will be obtained the value. Here also salary, 60 is the given value minus minimum value from the salary column. 70 means from the salary column maximum value 110 minus whatever the value it is, like in the salary column, what is the maximum value? 110. 110 minus 60 is going to become a 70 is going to be the value. So that if we get the value 0.27 is the age and 0.29 is going to the salary. So now we have to plot all these in a searching space. We have to plot the values in a searching space. We have to plot now. So age is going to be 0.27, the salary is going to be 0.29. So we have to check the distance between each particular value in the searching space among the all. Okay. Now, what is the distance, Euclidean distance formula? The distance between 2 points is going to be calculated mathematically, that there is an x1 is a given value minus x2 whole power square plus y1 minus y2 whole square and square root. This is the formula which is called as an Euclidean distance to calculate between any 2 points. Here there is a 1 point. Here there is another point. So if you wanted to calculate the distance between 2 points, absolutely we are going to be calculator. This will be called as a x1 and this will be called as a y1, y2. x1, x2. This is how we are going to be calculated. Between 2 points, the distance will be calculated with the help of this particular formula. Now the point is, now firstly, we are going to calculate 0.0. What does it mean? I have taken k is equal to 3, right? K is equal to 3. If you take 0.0, what does it mean? Absolutely, if you go to the here, absolutely, here you are taking this P1 and 0.10 is P2. Absolutely 0. What is that next point you have taken? 0.0, 0.10, 0.14 and 0.83, 0.71, which means what? Absolutely, we are taking randomly P1, P2, P3 as the K is equal to 3. K is equal to 3. And we are taking this particular value, this value and this value. And this value 0, 0.14 and 0.71. So here absolutely we are taking the calculation to find out the distance is equal to probability of P1, we can say that 0, 0 we are taking, and the distance we are going to calculate it, that P2 of 0.10 comma 0.14, 0.83, 0.71. This is how we have taken here. Please understand here. So I have taken 0.0, which means what? In the Euclidean distance, if we calculate the values, absolutely x1 is absolutely 0.27 minus 0 plus 0.29 minus 0, which means absolutely if you look at very carefully, 0.27 is the unseen data. We are calculating the distance, such as this is the x1, and absolutely that 0 is going to be the x2. Here x1 is going to be this and x2 is going to be this 0, and y1 is going to be the 0.29 and y2 is going to become a 0 because from the column. Okay, so such a way that here distance between this we are calculating such a way that okay, 0.396 will be the distance, which means what? In the searching space, the red is going to be treated as unseen data, which is going to be the 0.27. 0.27. Now x1 is what? Absolutely, x1 is 0, isn't it? And y1 is going to be the 0. Yes or no? For this particular point, we can understand. For this particular point, we are calculating the distance for this particular, so that 0.96. Let us go with the next P2, 0.10. This is the age and this is the salary. This is the absolutely age. This is the age. This is the salary, which is the unseen data, and this is the salary, which is the already calculated data. So that we are going to calculate the value is going to be the 0.226. Okay, apart from this we are going to calculate it. The third point is that 0.83 is the age and 0.71 is the salary. And here absolutely unseen data, this is the given. Now we are finding the distance between the existing assumed salary and data, and unseen data we are calculating the distance. This is the absolutely existing age, and this is the unseen salary. This is the already existing salary, so that 0.70 will be the distance. Okay, now 0.70 is distance, 0.226 is the distance, and 0.36 will be distance. Now what is the next step actually? So if you calculate all the things, like for all the rows it is calculating P4, P5, because we have taken only I think 5 samples, right? So here if you look at P4 will be 1.0 and P5 will be this 0.7. So when you compare with P1, P2, P3, P4, P5, I think the distance will be lowest for the P2 let us go ahead so that you will be able to understand. Okay. If we sort the above distances, if you look at now, P2 is having lowest distance, 0.2 is he buying the laptop? According to sample, no. And P1 is 0.3 is the distance. Is he buying the laptop? No. And P3 is 0.7 is buying the laptop? Yes. P5 will be 0.7 is the distance between the unseen data to the existing data. Is he buying the laptop? Yes. Is he buying the laptop? Yes. Now what I'm trying to tell you is that here I'm taking top three. The top three is going to be the lowest distance, right, between the unseen data. I'm going to take this. So like what I'm trying, neighbors I'm taking, like, you know, in this particular point, let's suppose the P2 is existing here, and P1 will be existing here, and P3 will be existing here. So for the given sample, which is called which is given called, probably the point will be here. If you look at the P2 will be very closer, which is going to be 0.2, and P1 will be little away, and P3 will little away, and P1 is also little away. This is how the point is the closest to that. Now the point is we are going to conduct the voting system now. In the three points, whichever the points are belonging to the category called as a particular category, the voting will be no, right? Obviously, more points are not buying the laptop. Only one point is buying the laptop, which means that if we go conducting the voting, no or two, right? Absolutely yes will be one. Hence, with the final category is going to be assigned the value is that age is 30 and salary will be not buying the laptop. This is how the prediction would be happen over here. The prediction will be happen over here. This is how the prediction will be takes place. Are you clear? So please, you know, if you have any questions, you could ask me. I think this is the process through programming. It is going to be learned now. Please, if you have any questions, you could ask me.
Sir, if majority is no, then it's no.
Correct. If majority will be yes, it will be predict that the given unseen data will be belonging to no, or else yes. So whatever the top three you have taken, right? Top three distance.
Yes.
So that it is going to be given to you. Yeah. So even the K-means algorithm, which is the unsupervised learning, is also having more or less, it will be follow the same kind of a situation. Tomorrow I'll tell you about the K-means algorithm, where the data shouldn't have a label, but the KNN should have a label.
Okay.
Yes, that's a difference. Supervised learning, always the data should have a labels already in the sample data set, which is to be trained for the algorithm. But unsupervised learning data, that there is no column is going to have in the data set, which is the label column. Only features will be there, x1, x2, x3, x4, like that. So I'll teach you tomorrow the same K-means algorithm, so that you will get to know how the difference between KN and as well as and that is also going to follow the same algorithm called as Euclidean distance. Clear?
Okay, sir.
Guys,
Yeah.
please, I hope you are listening, everybody. I think you are showing attention towards this. Aruna, Devi, Satish, Rashekar, Maste.
Yes, sir.
Yeah, so please see, the only thing is I'm expecting. See, doing the execution of the Python program with a scikit-learn is not a great matter. That's not a greatness of the data scientist. There should have a knowledge about a mathematical perspective, because in the scikit-learn, just a name is going to perform entire the process. It does not mean you are a great person, because mathematically you should know how the steps are going to be takes place. Please, that's the attention I am expecting from your end. Now let us go with implementation of the KNN through the scikit-learn. Yes. Yeah. Now I'll be implement this. So absolutely, first step is going to be load all the adequate libraries. Import required libraries. That here I required, import NumPy, import pandas as PD, NumPy as an NP, and absolutely import, from the sklearn dot pre-processing. Please let me connect. It will be show you whether the function or a method is existing or not. So dot pre-processing, you see, pre-processing, import min-max scalar. The next is that from scikit-learn. The moment it has to be show you, which means that it is existing. There will be neighbors will be the a class which is belonging to scikit-learn, where import, isn't it? K nearest neighbor, K nearest, K neighbor classifier. Yeah, K neighbor classifier. Okay, and absolutely from scikit-learn dot model selection import, where exactly we'll have a train and the test split would be required. Absolutely, it is required for the supervised learning. You know very well, sklearn and the dot metrics, where I'm just importing, that will be the confusion matrix, comma, accuracy score. Yeah. Even you could able to show absolutely classification report. Right. I think these are the adequate libraries in order to implement this. Next, go ahead. Let me create a sample data set. Create sample data set. You can take a sample data set here. Otherwise, you can able to take a Excel sheet also. So where let me create as a dictionary, where there will be the age is the column, where age is the column, where I'm going to take certain ages belonging to certain things. Like 22 is the one category age, 25, 47, 52, and 46, 30, 34, 40. Like randomly you can take the certain samples. Then absolutely we'll have another column called as a salary. So salary, okay, colon. Here I'm going to create certain samples in terms of the thousands. Like 40,000 will be the salary for the person who have a 22 years, 50, 90, 110, 95, and absolutely 60, 65, 70. These are the samples. Okay, how many samples I've taken? 3, 6, 7, 8, and yeah, absolutely. The dimensions will be important. And lastly, there is a column is called as by whether the candidate can buy the laptop or not. So where I'm taking what? Absolutely zeros and ones I'm going to be taken. 0, 0, 1, 1, 1, and 0, and how many done? Okay.
Six.
Okay. Yes, 1 second. Just, the classification. Randomly you can take the things. Probably 3 ones, 0, 1, 1. All right, 8. Yeah, okay. Yeah, that's all. The data is I created with a NumPy. Like, it's not a NumPy. It is a nested list we can able to say. Okay. Then absolutely we can convert the given data into data frame. Convert given data set as a data frame. That absolutely data frame is equal to pandas dot data frame is the method with which we can able to create the data as a data frame. So you can display that. Absolutely data is going to be created here. 1, 2, 4, 8 samples you have. Yeah, clear. So I think everybody till here completed. It's a time to split the data into according to supervised learning, according to supervised learning. Always we have to divide X variable as input features or independent variables, and Y as target variable or dependent variable. Clear? Absolutely, we can able to go X as data frame of where the columns are going to be the age, comma, salary are going to be treated as the yeah, they are going to be treated as input features. So when more than one particular variable you are assigning, so within the square brackets, another square bracket is required as a nested. Then Y is going to have only one particular variable, which is going to be the by. So with which the data is going to be split into X and Y variable. X will belonging to input features and Y will be belonging to, let us check whether they have created or not. Yeah, only age and salary will be input features, and absolutely we can go with the Y. That is going to be the output feature. And guys, I hope till here everybody is clear, right?
Yes, ma'am.
Yeah. Yes, absolutely. The next step is feature scaling. So even though we have seen in mathematical steps also, right? Absolutely, I'm going to take a scalar where exactly and min max scalar is a built-in method in pre-processing of the scikit-learn, where exactly we are going to take x scaled is equal to scalar dot fit transform. Yes, just you pass the parameter called x. Absolutely. Now execute and you see the output. Absolutely x scaled. You can see how the data will be get scaled. You see 0, 0 0.1, 0 0.8, 1.0, 0 0.8, 0 0.2, 0 0.4, 0 0.6. So always the min-max scalar is going to be scaled between 0.0 to 1.0. That is the scaling of the point. Whatever the point you see in between them, it shouldn't be go like a 2.0, 3.0 like that. So any algorithm, machine learning, either supervised or unsupervised algorithm, the values will be within the range of the 0.0 to 0.10. Millions can be. so that it is easily understand, it will be easily learn, quickly learn the things and it will be predict easily. That's the main motto between the main motto related to min-max scalar. Okay, let us, I think once the min-max scaling is done, it's time to divide. It's time to divide. Split the data set into k-fold validation as 4. What is that? Absolutely, I could able to say X train, comma X test, comma Y train, comma Y test is equal to, absolutely, we can call, there is a function is called as a train underscore, yes, train underscore test underscore split, where what is supposed to give as an input? Absolutely, X scaled has to give, because the scaling value has to be given. And absolutely, we can give Y, isn't it? The test size is going to be the 0.20 or maybe 0.3. Means 30% of the data will be test data. 70% of the data is going to be the training data. Okay. Okay, done. You see now what out of the 8 samples, how many values are divided as a X train? Probably 70%, which means what? 70%. This is the X data. This is the Y. This is the X2 data. This is the age column. This is the salary column. So 1, 2, 3, 4, 5 will be 70% of data have taken as training data, and salary columns also 70% of data considered as a training column. Let's suppose the X test you see. Yeah, 3 samples will be as a test data. Okay, similarly, Y underscore train, 70% of the test like a train, like a, sorry, what happened here? Yes, sorry, Y. Yeah, 5 rows will be taken as a train of the target column. Similarly, Y underscore test is going to be the 3 columns. So till here, I hope everyone is understand that. Yes or no? Yeah, yeah.
Yes, sir.
Now we are going to call, there is a function is called, we are going to write, there is a function is called Euclidean distance will be as a function. Euclidean distance as a function where I'm going to give x1 comma x2 will be the values according to the mathematical perspective. So how it is going to be calculated over here? Absolutely, it will be written the value such as the numpy dot, there is a function is called as a square root of numpy dot sum of x1 minus x2 and absolutely the square, exponential as a square. This function will return you whatever the distance will be calculated for every point and which is the unseen point will be done. So function is available for us, yes or no? Now it's a prediction is going to happen now. Prediction is going to happen now. Predict, isn't it, manually, which is going to be yes, we can take a variable as now I think we'll be taking as a comment predict, yeah, predict manually, that absolutely manual predictions is equal to what I'm doing here, manual one second, just hold on. So one thing we'll be doing one thing. Just hold on. See, there is a 1 second. See, do one thing, like don't we create a manual predictions, because it will be get confused for you, because we are some completely using automation, right? Which is the built-in k nearest neighbor algorithm, right? Let us go with what is called sklearn KNN classifier. Like how exactly would happen? You know, the KNN is going to be k nearest neighbor classifier. This is the algorithm we are taking, and KNN dot fit of x underscore prime comma y underscore prime. Yeah, okay. These two are going to be given. So where exactly I'm going to be do the predict, like let me the classifier is trained. Now we are going to perform the predictions. So where scikit-learn sk predictions is equal to knn dot predict, where I'm going to give x underscore test. Yes, sorry, x underscore test means 3 samples are going to be given to you. So once it is done, now what I'll be doing, it can be, you know, it can be shown to you predictions. Now it will be predicted some values. There are 3 samples. The KNN will be predicted as 1, 1, 1, isn't it? So now voting, everything will be done during the predictions. Yes or no? And now absolutely we are going to be show you confusion matrix. Confusion matrix, where exactly we can able to CM is equal to confusion matrix, where I'm going to give, there will be a y underscore test comma. Now just now we have created a sk underscore predictions, so that in between them this confusion matrix is going to be drawn to you. CM. You see here, out of the 3 records, 2 records will be perfectly classified, 1 record is misclassified, isn't it? So this is a confusion matrix, isn't it? 0, 1. Right? Even you can see now what is called as a classification accuracy. Classification accuracy. That, you know what? Print classification accuracy. Classification accuracy report of same, you can give, you know, y underscore test, comma what is called sk predictions. Now if you look at it, will be give you the accuracy. So the accuracy of the model is going to be 67%. Absolutely, this is going to be the precision, and for the classification of 0, and to classification of the 1, 80% is perfectly classifying, isn't it? So as the data will be get changed, accordingly it will be get changed, isn't it? So for the given data set, this is an accuracy actually. Precision of the model to classify the 1 is 80%. Precision of the 0 to classify is 0%. Means I think there might not be record in the 0, because all the predictions are 3 ones actually. Therefore, it is able to predict 2 ones are perfectly, 1 is misclassified. Therefore, it is 80% is classified. Overall accuracy will be 67%. Only to classify the 1 is 80%. Yes or no?
Pre
So this is how.
precision will be 67, like 0.67.
Correct, 0.67, because the accuracy will be
Yeah.
both true positive plus true negative divided by true positive,
Yeah.
true negative, false positive, false negative will be calculated. Therefore, it overall accuracy is 67% of KNN. But to classify only belonging to the zero category uh, samples, it will be in the test sample. We have taken only 3 samples, right? There are no zero category of the sample, hence it is taken as 0%. If there
Yeah.
are samples you have taken with 0 also, the precision would be changed accordingly.
Yes, sir.
That's why you just increase the size of the data set. If you increase 300, 400 samples, so that the accuracy, precision, recall, all these will be get changed accordingly. Yes or no?
Yes, sir.
Yes, yes, absolutely, absolutely. Yeah, I think the mathematical perspective is in detail. I have explained to you how exactly the distance will be calculated, how the voting would be happen. Very meaningfully we have understand. Whereas the scikit-learn, how it is calculating distance, Euclidean distance, all this we don't know. Simply it is giving an accuracy. So therefore, implementation of any algorithm is not great if you want to execute through scikit-learn. But if you don't know the mathematical perspective behind an algorithm, surely I can say you are not a good data scientist. Because the fine tuning parameter, the questions are asking like a Rajalakshmi, like a, sir, why like that? Why like this? This kind of a doubts I'm expecting from you. Yeah. So Aruna, yeah, she raised a coin. Aruna, are you there?
Yes, sir.